Welcome to Chatting Around the Campfire. This week's episode is presented by Red Raider Robotics. I'm Erica.
I'm Flinn, and today we're joined by Noah and Jack. They're both members of programming team, and today we'll be discussing the role programming team has on the robot and the team as a whole. So let's get chatting.
So boys, how did you get into robotics?
Well, initially, I heard that it was pretty cool. So I went to the, our high school has an annual, kind of a club fair at the beginning of the year for freshmen. So I went up to the robotics kind of area and talked to them for a little while, and I don't know, they all seemed pretty nice, so I just signed up.
Jack?
Well, I started doing robotics in middle school with FTC, and my brother was in it, so I decided to join, and then I didn't leave.
Yeah, it's the story of our lives. How many years have you been on the team?
I've been on the team for 2 years.
Yeah, me too.
All right. What is your guys' favorite memory or just best thing overall about robotics so far?
Probably the competitions, actually. Programming is fun, don't get me wrong, but watching the robot do what we programmed is pretty exciting.
Mm-hmm.
Yeah, I agree. I think that the, big competitions, those are the best part, to me at least.
Mm-hmm. And then starting to dive into programming, what do you guys specifically do on the robot? What's your role in the team?
So in the FRC competition, the first 15 seconds of the match are autonomous based. So my role is to kind of make the robot do stuff in autonomous.
Yeah, last year I did a bunch of stuff on Endgame. This year I'm more helping with data analysis, which I guess isn't really programming, but that's what I do most of the time.
Mm-hmm. All right, well, we've gotten into programming a little bit. Noah, I know that you went to a summer camp this year at Kettering. Do you want to talk a little bit about that and what you learned from it and what your experience was?
So Kettering is a university in Michigan. It's based on kind of STEM, engineering, all that kind of good stuff. They offer FRC teams. It's like an autonomous day camp. So you go there for, it was 5 or 6 days. and you basically just programmed for the entire day. So you team up with 3 other kids. So I got pretty close with my group of friends, actually. We still keep in contact and everything. But we basically, they gave us challenges. So they said they gave us all robots. There was 4 or 5 FRC robots from previous games. And they gave you the robot, and they gave you a bunch of different challenges. So you gotta move the robot to a certain spot, score a point, or a bunch of different kind of things. So we spent the entire week just kind of programming the robot, messing around with different software, which it was pretty fun.
How have you been able to translate what you learned there into this season and our robot?
So we're still kind of working out the kinks, but at Kettering we worked with Path Planner, which is a software for FRC robots where you can basically plot out an autonomous route and then use kind of I'm gonna go into some programming terms, but a sequential command group, right? You can throw in commands during the path, so you can tell your robot to do almost anything autonomously. That's what we did at Kettering, and so I've been trying to implement that into a serve drive, which is proven to be fairly difficult, but I don't know, we're getting it to work.
So, as a business team member, again, don't know much about programming. So, you laughed a little too hard at that. Anyways, so there's only one robot. Do you guys all work together on the same code? Is it you each make your own code and that's how it works? How does it get translated over to the robot?
Well, we have 2 robots, actually. We have Tooth Grinder and Tooth Gnasher. So one's a competition robot, and one's a robot that we kind of just solely use for testing. And we use a software called GitHub, which basically has these things called repositories, which we put our code into. and then we can deploy that repository to the robot, and we run it, and then it runs that specific repository. So we have multiple different repositories, and normally what we do is we have kind of a repository with the same base code, like the same kind of drive code and basic stuff like that, and then we kind of all branch it off from there in our different repositories. And then we sometimes also use the same repository, which is like our main repository, I guess, and we like make branches of that. So we all kind of work independently from each other, and kind of like at the end of the competition season, we all kind of put it back all together to have like one big working code with everyone's stuff in it. So.
And you mentioned we have 2 robots this year. That's new. You were both on the team last year. This is your second year at least. How has it been helpful to have 2 robots?
Oh my gosh, it's been so nice. We like our productivity has like gone up like significantly. That sounds a little cliche, but like our team lead Aria has been able to work on kind of something that she's been working on, and then I've been able to work on my autonomous like route planning and stuff. So it's enabled us to kind of work at 2 things at once. Because last year, I mean, we have multiple laptops to run with the robot, but you can't run 2 codes to the robot if you don't want it to blow up. So, you know.
Yeah.
So, Jack, I know that Noah talked about his experience in getting into programming. How did you get into programming?
Well, this team was my first experience really programming robots. I had some experience with other coding, but that was more like website coding. So it's pretty different, but a lot of the same, like, I guess, logic to the code still applies and carries over. So I had some experience with that beforehand. Was my first experience.
Yeah, you mentioned different types of code. Can you like talk about what? There's like so much that I don't know about programming, and a bunch of people don't know about programming. Like just the basics and stuff like that.
Sure. So what we use for our code is called Java, and Java will like run on the robot. It controls all the motors, does all that, and that can like control a machine, you know? Mm-hmm. The other programming languages I've used in the past, like JavaScript, HTML, some others I'm not remembering right now, those will work like on a web browser and just like, you know, display information, and so it won't, like, if you try to run it on a robot, it won't change the motors at all. It'll just try to display a picture or play a noise or something like that, but then both of them, like JavaScript and HTML, as well as Java, can all do like calculations and use variables in a similar way to change what it displays or runs. So they both have similar, like, I guess, interior workings, but then they show that in a different way.
You can almost think about it like you can use the analogy of like the English language to the Spanish language. We use the same alphabet and we like portray the same ideas, but like the 3 main programming languages that we use in robot programming is Java, JavaScript, and C++. So they all portray the same idea. The robots all do the same things. It's just a different way of getting there, right? So, right, it's like in Spanish and English. It's the same ideas, the same alphabet, the same way of typing it out, right? It's just rearranging it a little bit differently.
Is there like not necessarily a better language for a certain task, or would they all work compatibly?
Yeah,
I was just going to say, like, you could really use whatever you want to get to there, but there's definitely some languages that are built for different purposes more specifically, so it's easier to get there, and, you know, you could write everything all in JavaScript, for example, but it would be harder.
Yeah, and Java, especially the code that we use, is a lot more user-friendly. So I know me personally, I actually had like completely zero programming experience before I joined the team. And while it was still hard to learn, right, it's probably still going to be the easiest. So I went from like not being able to program at all to I'm a pretty fluent programmer now. So it's just easier for people to learn.
So in the field of first, I know you've been on for 2 years. How do you think that the competition setup, or the game has changed? Which one's harder?
I mean, the programming is pretty much the same for almost all the things. It's just what you're programming, right? So for last year's game, right, we had an intake and we had to shoot the ball out of the intake and score it in the hub, right? Which is a whole kind of different area of programming than this year when we're using like an arm and stuff like that, right? So like last year we had to program all the flywheels, right, to shoot the ball and like kind of calculating where we want to be and the different powers needed for the flywheel to get the ball actually in the hub. But this year it's more motors controlling the arms and like extending it and different stuff like that. So there's never really more programming, I guess I'd say. It's just different. So, and then I know last year we used a mechanism drivetrain, which for people who don't know, it can move forward, backwards, and then it can strafe and kind of move at a diagonal. And then a swerve drive can basically like rotate. It's got two motors. It's got a turning motor and a drive motor. So it can basically rotate like in place. So that's provided a whole butt ton of issues. It's just different programming, different stuff to get used to.
Is that like something that has been a like really big change? I know, like when we were in Sussex, I overheard a team like they needed help programming their swerve. Like, how did you manage that transition?
We have a lot of knowledgeable programmers, whether they're from the past or the people that are on our team today. And there's so many good resources out there, like Chief Delphi, and then we use GitHub, and you can literally go to github.com and literally search up anything, any public repository that's been posted, you can look at, right? So there's so much source code, there's so many examples, and not to like toot our own horn, but we're all pretty smart, right? So we put the stuff together eventually, right? But it's just a lot of trial and error and testing, and you get there eventually.
All right, we now have switched out Jack for Aria. Aria is our programming lead. Yeah.
Yay!
And like first things first, I know as a business team lead, we had like meetings before the season to talk about how we're going to teach new members of our team. And I know you put a lot of work into your lessons. Do you want to talk about how you formulated each of those, and then also Noah, like what you gained from those? Or were you here?
Yeah, no.
He was at swimming, I think, right?
Yeah.
So basically, well, first thing, I organized all of Basecamp. So Basecamp is kind of where we include all of our docs and files, and basically how as a team we communicate with each other. So I looked and I organized all that, and I kind of just found a bunch of slideshows that didn't really, they weren't very cohesive, and they didn't really flow from one to the next. So I don't even know what order it was supposed to be taught. But basically, I looked through all of them, and I kind of laid out what we have previously. And so basically, so then I made a list of all the things that I want to have, and I looked at some of the problems from our previous years. So I noticed that like our previous manuals, they were mostly about how to program a computer, not really how to program a robot, which you need the fundamentals on a computer, such as how to use an if statement, how to use a while loop, for loops, that kind of things. But I noticed a lot of the stuff wasn't really important, so we were spending time on things that we weren't actually going to use in the normal season. So I tried to cut back on that so that we could actually have time learning how to program the robot, because that's not something like when I was a sophomore, that was my first year. Granted, it was because of COVID. I didn't really have any experience actually programming the robot in preseason.
Mm-hmm. And we talked about this a little bit with Noah and Jack. How did you get into programming?
As a freshman, I took my first computer class and I really, really liked it. Like, I'd always been interested in STEM stuff, but when I took the computer class, I was like, oh, this is something that I actually get and I understand, and I feel like it's good for me. But I was in the youth orchestra, and so my mom didn't want me to do like too many different things and get overwhelmed. So my freshman year, I really wanted to join robotics, but I didn't join until I was a sophomore, and that's when we were in the middle of COVID. But it was mostly just like, I think I'd heard about it from someone at church who was in Robo Riot, I think.
Mm-hmm.
So we talked about this with Noah and Jack. What is your favorite part of programming?
Well, I think in general, my favorite part of programming specifically is, when you have a robot that you put it all together and you wire it and you build it and design it, it's really cool. And that takes a lot of work and talent to do. But I think the part that I like about programming is that the robot can't really do anything unless it's actually programmed. Like, it's kind of just sits there. But when you can program it, you're basically taking it and like making it alive and that kind of thing. And all the different functionality that the design team and the build team all worked for is finally able to like work once you actually make the motors work and do all that kind of stuff.
Yeah, you mentioned like making it come alive. How do you do that in a safe way? Like, I've seen videos of like robots in autonomous just like going full speed and then crashing.
The other day I was working on my autonomous program, and it was a little bit too close to a metal table, and I enabled it and I had it facing the wrong way, and it smashed into the metal table. It didn't break anything, but it's such a, like, you just need to be aware of what you're doing and yell out robots turning on, so you hit a metal table instead of a person. But
Okay.
Yeah, things like that.
Yeah.
Things like that.
So you talked about the robots coming. This is a little off topic, but you talked about the robots coming alive. Do you think robots will take over the world?
No.
I think programmers will take over the world.
Yeah, I think that's true, but I don't think the robots will.
How do you think programming will
Evolve.
evolve, and what you've learned here, how will you use it in the future?
Well, I'm going to LTC right now, so I'm going for my web and software associates. So I think just like having that experience, it's definitely something that I want to pursue further after high school. So I think first is a good way for me to get a lot of that experience and the problem-solving skills that'll help me in the future.
And I think just when we look at programming as a whole, like 20 years down the road, I don't think it's going to be extremely different. I think it's just going to be easier. Like software already exists. Like I was saying, like with my autonomous path planning, right? We're using a software now called Path Planner, which is like really, really user friendly, right? It's a little bit harder to like put into the code, but it's kind of worth the wait because it's less of like kind of programming a trajectory, and it's more like just clicking your mouse and like moving it where the robot wants to go. So I think just the software itself, like used for programming, will just get like exponentially better.
What are the biggest challenges that you guys face when it comes to programming?
Probably not knowing where the actual error is residing. So when you're programming, you have a lot of red lines that can tell you, oh, here's an error, or a yellow line means that you've initialized something but it's never used somewhere else. But there are a lot of errors that don't have red lines under them, and you don't actually know where they started. So for example, one of the errors we get is a start competition error or a null pointer exception error, and that pretty much just means somewhere in the code you're having this particular error right here, and you kind of have to know what those errors mean so that you can know what to look for. But when you think about it, our code is like thousands of lines over many different files, so you kind of have to know the structure of it to be like, oh, this is this error we're getting. It's probably going to be somewhere in this area. Not to mention, sometimes it can look like it's a programming error, but it's not actually. For example, sometimes the electrical can be a little off, and that can be causing an error. Or sometimes, like recently with the sliders weren't working as they were supposed to, but that wasn't actually the programming. That was because the CAN Spark Max encoder kept being unplugged, so that slider motor wouldn't actually move. So sometimes it's pretty much just like, I know how to fix an error, but I need to know where the error is actually coming from. That can be the most difficult.
And you talked about Spark Max. I know like that is something a tool that you can use. There's like Limelights. There's obviously this word drive that we have. I don't know where I'm going with this. How do you like bring all these tools that you have together and like
Yeah.
April codes too?
So when you're thinking about programming, it has different components. So the main ones would be motors, encoders, and sensors. So motors, obviously, like moving something like a wheel, or like, for example, moving the sliders up and down. And then an encoder is actually something that measures the revolutions of something. So like if you have an encoder on a clock, you can tell what time it is, that kind of thing. So we use that. Those two things work together, and then we have sensors on top of that. So for example, like you basically just say, this is what I want to do. How am I actually going to do it with your resources? A lot of it is saying, like, this is what I have and this is what I want. How am I going to get from step A to point A to B? So, for example, with the sliders, we have our motors on it, and then the motor has an encoder, and I want it to go from like here to here so that we can place an object. You basically just say, okay, I'm going to measure out where those encoders are actually going, and then I'm going to program and say, if it's above this certain point, set the motor to a specific speed, and then once it reaches that point, you're going to set the motor to 0. It's obviously a lot more complicated than that, but on a basic level, that's how you do it. And then for a sensor, it's pretty much just, our goal is to make it as easy as possible for the drivers to drive. So one thing we're trying to do with the sensors this year and the April tags, with the limelight, what that does is, it sends out the light and then it hits a reflective tape, and then it's going to send it back on the camera. And then you have the middle of the camera, and then the camera can do math to basically say this is where that reflective tape is sending back and you can get values off of that. So you can get TX and TY, and that's basically saying how much different that is on the X-axis versus the Y-axis. Then you can take that number that you receive, and then you can set the motors using PID, which is it's like a mathematical formula, and then that can basically tell your motors to set to a specific speed, and because of that, then you can if you bind that command to a button, then when you press the button, then it's going to try to line up the robot with the limelight, and so that's just kind of the process in that scenario.
And then we also, to kind of answer your previous question with this question, we have a lot of generous sponsors, right? So we're able to kind of access new technology and new software all the time, right? And the keyword there is new, right? So like we get limelights and we get like a swerve drive and all this type of like all this stuff, right? Which is amazing for like making our robot better, right? But it's also like new hardware and new software, right? That we don't know how to use yet. Right, so I think that's definitely my biggest struggle in programming, right, is learning new things, right? Because we can be comfortable with just like using like basic code to just tell the robot where to go, right? Or a bunch of different stuff like that, or to align the robot, or to do a bunch of different mathematical calculations, right? But right, that takes longer. It's not as effective, and while we stay in our comfort zone there, we could use new technologies like limelights, like swerve, all that good stuff. Right, that makes our robot better and makes us do better at competitions, right? But then we need to learn how to program it.
And to add on to that, for example, last year we were using a Limelight 2. We didn't actually this will be our first year to use Limelight in competition, but last year we were using a Limelight 2, but they came out because the game changes every year, and we have April tags. It's actually using the same Limelight. So with the Limelight 3, you can actually program it to use fiducial tags, which is like, I don't know why they named it that in the software, but instead of using the camera to detect the Limelight reflectiveness, you can use it to detect April tags. And so now it's like, it's this whole new thing that we can learn because of the game. And I think that's why it's cool that the game changes every year, because you have to change and adapt to better fit that.
And this is also off topic, what are your thoughts on the game this year? Do you like it? Is it better than last year?
I think it looks
overall
eerily similar to the FTC game, but it's the same company, and I think it's just like FTC is a great starting block for FRC, right? But it's such a big step up, right? We're able to do so much more, right? So I think I'm personally okay with it.
I like the game because from a programming standpoint, there's a lot more you can do with it, I think. Now, I don't know how much of that is like how different as a programming team we are from last year, but I think that this game has allowed us to use a lot of new tools that we didn't last year. And I think because, the ARM is really a lot I think that the secondary driving is maybe a bit more complicated than it was last year. So we as a team are kind of pushed to make it easier for them. And so we have to have a lot more things that are set. So for example, we have sliders. And the sliders, you press a button and it automatically goes to a specific place. That's all programming, you know. Anything that's automatic is programming. And then also we're doing the same thing with the manipulator, because then the manipulator goes like this. You want to be able to press a button to go right here versus right here versus right here, like that kind of thing. So that's all programming. So I like that about the game, is that we're able to do a lot of different stuff with it.
Yeah, and how much, you mentioned ease of use for Drive Team. How much communication do you have with them?
A lot of communication. I've done a lot of like practice driving with Max just to see this is what I need to do, this is what I need to change, and I think that that's really helpful. And then Max and I are always like in a lot of communication about what he wants changed. So there's definitely a lot of communication that goes with programming and Drive Team.
And there's also like, you got to think about it to make it easier for a drive team, right? So we can have really advanced code and it can do something really cool, but if they don't know how to use it, it's kind of useless.
What do you think has been like, I don't want to say your biggest regret, but what's something that you thought was going to be a great idea and then you realized that this just isn't going to work?
To be honest, for our programming, I think if we're saying that it's not going to work, we're not trying hard enough, right? Because there's so many different ways of programming things and new things we can use, right? So while we might not get it to work this year, right, then it's a summer project or a preseason project, and we can like build off of it. So I don't know, Aria might answer some way differently, but
I kind of like disagree with that to some extent, because I feel like I think that the stuff we've done this year is really important, and I'm glad that we've worked on the stuff we have this year. But one thing that as a lead I really wanted to work on is last year we kind of started a lot of things, but we didn't finish a lot of things, and that's something that this year I basically said, I want to use command-based, I want to have some sort of trajectory for our autonomous, and I want to use sensors. And so we've done all three of those this year. And so that was a big thing. I was like, I've seen it happen in the past when you bite off more than you can chew. This year, I was just like, I want to have a few big things that'll really help make our programming team better. And I want to be very clear if like, I don't think something can happen, because I don't want to spend my time on something that I don't think is going to work. Like in the previous years, we worked a lot on LiDAR. We've never used LiDAR. I don't know of like any other teams that have used LiDAR. LiDAR is just a different form of it's a different sensor. And so I kind of looked at that a little this year, but I think this is the first year in like maybe 2 or 3 years that we haven't really used LiDAR, because we spent a big chunk of the portion of the build season and then we don't get anywhere with it. And so that's not something I really wanted to do this year.
And kind of wrapping things up, what would you tell someone, or like how would you connect someone to programming if they're interested in programming in robotics?
it's super duper hard, but it's so worthwhile. Like, it's so much fun. Like, once you know what you're doing, and that was something that I struggled with. Like, I had zero experience before I started. But, like, now, getting into my second year, where I actually, like, know what I'm doing, it's so much fun to see what you program actually work.
The final result.
Yeah, right? Like, last year, the only memorable thing I did is I'm pretty sure I programmed a couple buttons, right? So, like, when you pressed a button, someone else made the command, and I just made the command run when you press the button, right? That's kind of cool. But, like, this year when I can, like, see myself programming autonomous, whether we use it in game or not, I see the robot do that autonomous, that's pretty cool.
I would say for me, if you're interested in robotics and programming in specific, the biggest tools you can have is, I would say, being detail-oriented. Like, obviously, there's a lot of different, your code is based on individual lines, and you have to be able to look through that all and figure out where the problem is. And also, if you're a problem solver, programming is very much problem solving because it's a lot of testing, and it's never going to work on your first time, and you just kind of have to get used to that. So I'd say if you like a challenge, it's very fulfilling because, again, you're going to fail so many times, but then the second that it actually works, it's going to be like just the greatest feeling, and I think that's why a lot of people really like programming.
All right. Is there anything else you guys want to add?
join programming team.
Yeah, we don't have very many people.
All right. Well, thank you for joining us on this week's episode, and we'll see you next time around the campfire.